Here we have 100 horsepower, and we're going to put it into an RC car to build the fastest RC car in the world. Raz did 196 miles per hour on one of these motors, and we're going to use 4 of them. Tony's got the world record at 208 miles per hour. So we've got the same car, and we're going to put these 4 motors into that car. So no idea what's going to happen. It's either going to be stupidly fast and smash the world record, or it's going to be the world's most expensive radio-controlled car crash. Either way, it's going to be absolutely epic. This is the Hobeo VTE 2. So the motor is supposed to go there. No chance. And we got to get all 4 in. With a little bit of modification, we might be able to do it. But we still need to get more stuff into it. 4 speed controllers, radio gear, and 8 4S lipos. Oh my god, guys, all this has to fit into this. So here we've got the speed controllers. I'm going to be using the Castle XLX2s. Now, I've already had a couple of these catch fire in the past. Oh, guys, I just plugged it in. The whole thing's gone up. So hopefully these are going to be okay. So they're going to have to go like here maybe. And the batteries? Nope. That's what 100 horsepower looks like in this tiny little RC car. We're going to have to give it a little bit of thought. I've got an idea. Are you thinking what I'm thinking? Some of the world's fastest real cars are long and skinny. So let me present to you. Long and skinny. Oh, still won't go. So motor there, speed controller, another one, another motor, 4 speed controllers, batteries. Do you know what, guys? It's going to fit. And lengthwise, we're looking at probably going to be about a metre long. And Rosso rules, where we're going to run it, hopefully for the first time, they say the maximum length of the car can be half a metre. This thing is going to rip. Or blow up, one of the 2. So next up, we need a twin motor mount and another twin motor mount and some custom-made drive shafts and a custom-made chassis. So Scorched Parts, they make a twin motor mount and this beautiful-looking carbon fibre chassis. Trouble is, it's too short. Hopefully, they can make me a custom one. Hello! I'm building, hopefully, the world's fastest RC car. Can you help? I need a really long chassis. Yes! Thank you! Next up, we need some drive shafts. Stock drive shafts. At high RPMs, they can flap about and you lose loads of power. My buddy Raz Schifrin, he makes some carbon fibre ones. So hopefully, he can do me some custom-made lengths. Razzie! Can you make me some drive shafts, please? Pretty please? Yes! Thanks, mate! Bye! Guys, this build is gonna work. You watch. Maybe. Oh, it's Christmas every day! Oh my god, look at this! Look at the size of that! What? That is the biggest carbon fibre chassis I've ever seen! Got all these other parts in here, look, splitter, shock towers, other chassis parts. Massive thank you to David at Scorched Parts for custom making me this chassis. Scorched really do make some of the best RC products there are for speed running, for bashing. I'm going to put a link to Scorched Parts down below. Go and check them out, give them a bit of support, because Scorched are supporting potentially the world's fastest RC car on this channel. So I've got the instructions here. Let's get it fitted. I'll tell you what I really like about this Hobeo is if you look at this differential input cup on the front, it comes out perfectly straight. If you look at an Armour one, it's at an angle like that, and that puts severe wear on the diff cups and the drive shafts. So next up, I'm going to temporarily put some wheels on there just so we can mock everything up. So I think we're going to put 2 motors here, then 2 speed controllers there, another 2 motors here, and another 2 speed controllers here. Man, we got so much space on this chassis, and we got all this space along here for lipos. Next, we're going to need some motor mounts. So this is a stock one, obviously no good. Scorched Parts, they do make a twin motor mount to hold these motors. So if I put one there, another one there, and then a perfect pass drive shaft to go from here to there, another one on the back, I haven't got any for now, but something like that, another motor mount, and then I can either run it with 2 motors going to the rear axles, 2 motors going to the front axles, or I could tie it all together and have a long shaft joining it all together, so it's like all full 4-wheel drive 4 motors. So this chassis is made to fit an armoured diffuser. It just needs a couple of little modifications to make it fit around the carbon fibre. Splitter wires, a Armour Limitless one also fits. I'm going to go with a stock plastic one for now, because when I went to Rossa last year, the carbon fibre one, it was scraping on the floor. Every time I touched it, I was getting splinters. So for now, I'm going to try plastic. Next, we need a body shell. Now, I could make it look like one of those official speed running cars with all the wheels enclosed and no little cab thing on top. However, I want it to still look like an RC car. Maybe we could use a body from an Armour Limitless. And another one. Trouble is, open-wheeled cars have a lot more wind resistance, so not the best for aerodynamics. So here I've got a body from Delta Plastics. This is a Ford FC100. Obviously, it's way too short. But what about if we use 2 of them? It's going to be a bit of a hack job, but I think we can make it work. Next, we're going to have to completely lose the cab and the front end from the rear one. Ow. Man, this stuff's hard to cut. Jesus. What? Why is it so hard to cut? Jesus, it just won't cut. Man, this is a horrible job. There's no way this is going to be neat and tidy. No way. This is going to be a complete hack job. I'm not sure if it's going to join up that well. The body's quite high up on the back here. On this section here is quite low. I know it's always going to be a hack job, but this doesn't look like it's going to be that great for aerodynamics. So I think what I'm going to have to do is cut the whole entire rear end off of this body off and just get some 2mm Lexan and just make a middle section and just use that. And I could have probably just made it out of one body, but now I've ruined 2. Trusty eBay, lovely jubbly. And while we're waiting for that, we might as well see if we can get the servo mounted. So I'm going to be using one of these metal geared 56 kilo perfect pass servos. So this is how the motors are going to sit. There looks like to be just about enough room to mount the servo there. We're going to have to shorten this servo link though, because that comes out there. I think if we just join those 2 directly together, the grub screw is going to be perfect. Now I need to drill the chassis so I can screw this on. However, I want to wait until I get the motor mounts and the drive shafts just to make sure that it's all going to fit. Here we've got some carbon fibre shock towers. Now that we've got this shock tower installed, we can get this Armour Limitless rear wing and it's all going to bolt up. Oh, postman! Oh, it's Christmas every day. Check this out, guys. More Scorched Parts. So we got 2 dual motor mounts. One to go there, another one to go there. We've got front and rear diff lockers, titanium drive shafts, and this special drill bit kit for drilling carbon fibre. Now, I can't fit these yet because I'm waiting for Raz Schifrin from Perfect Parts to make me some custom-made drive shafts. Then we can fit the motors, put the drive shafts in, make sure it all fits in there perfectly before we drill the chassis. The last thing I want to do is drill holes into the chassis only for it not to line up. 4 posts! Check out all these parts from Perfect Pass. We got the version 2 Perfect Pass backed wing that goes on the back here. It's really supposed to be for the Armour Limitless, but because we got the Limitless diffuser on there and wing mount and all that, we should be able to get it to fit. Also, we got some Limitless body mounts. So a Limitless body mount will fit straight onto the front of the Scorch chassis like this. The rear one, we're gonna have to get the mount on there somehow. Perfect Pass springs. These are super hard, super heavy duty. These are supposed to be for the Armour Limitless. However, I'm gonna hope that I can use them on this car here. On a speed car, you want the rear end to be almost solid. If the wind comes along and pushes down the back and the front can go a little bit higher than the back, it's going to backflip. So you need to back super, super hard. And here we've got a piece of Lexan so we can modify the body. So here are the lines where I've got to fold it. I think I've worked it out right. We will see in a minute. So here we've got the old folder. Right, ready? Yep, we're ready, we're ready, we're ready. All right, here we go. High tech here, watch it shatter. Oh, beautiful. Here we got Barney, the technician, showing us how it's all done. Grab hold, ready. Oh, look at that. Back to the top and see if it works. So now on the front end, that can slide over the top like this so that the wind flows without going inside it. And then on the rear end, that goes inside it and it all fits perfectly. I'm so glad that Barney helped me use his folder. If I'd have tried and fold that over the bench like we did that sausage, it would have probably come out like that. So it's all looking pretty good at the moment. But next up, we've got to fit this Perfect Pass rear wing so I can line up the bodywork and make sure that it all perfectly fits. All these lines in here that are supposed to aid with the aerodynamics and keeping the rear end really locked in. Next up, to get the body to fit properly, I need to trim these bits here out and hopefully that's going to sink it down into the body. Trouble is, this on here says 2mm, so I bought 2mm Lexan. But if we measure this body here, we're looking at like 0.77mm. This was hard to cut, so this is going to be impossible. Nope. So next, I think it's best to fit some body mounts. So the front one, that's going to bolt straight onto the chassis. Remember, these are from an Armour Limitless. They're not supposed to be for the Hobeo. On the rear, there's not really anywhere to bolt it. I think we can make something. So I've got a couple of stock Armour mounts here. If we cut this off, that off, and you'll see, you'll see. Sorry, Raz. Yes, that is working a treat. Now look, when the wind's pushing down, that's not flexing the body down. It's got loads of support there. Front one's easy. Next, I'm going to fit the front and the rear body posts, get the front and the rear section of the body fitted, and then we can look at joining the two halves together. So I'm going to drill some holes, temporarily put some nuts and bolts through the holes, join it all together, make sure that it all lines up, trim it, then take it all apart again, spray paint it, and then we can finally put it together with rivets and have it permanent. Next, we can cut the bottom off. So this is just temporary. I'm going to cut more out of here. Once we get all the weight in there, suspension set, the tyres all set, then I'm going to cut this out after to do it properly. But you're going to get an idea of the size of it. Check it out. This one here's a normal size speed car. Check out the extended one. Man, this thing is going to rip. I mean, it just has to. I mean, how can it not? Comment down below. How fast do you reckon it's going to go? Let me know in the comments what you think is going to happen. 100 horsepower in this. I mean, it just has to rip, doesn't it? Postman! Oh, it's Christmas every day. Check this out. I've had the batteries just turned up. So I've got these lipos here from Onyx. So we're going to get 4 of them down this side and another 4 of them down this side. Motors, speed controllers. This, ladies and gentlemen, is what 100 horsepower in an RC car looks like. My God, that is heavy. That is heavy, guys. The suspension has fully decked out just with all that weight on there. So I'm just going to bolt these motors on here temporarily for now because we're not going to know what rotation to put them in until it's all fitted and the gears are on. So there's 50 horsepower. There's 100 horsepower, so that's going to go there somewhere. This one there somewhere. And to attach all this horsepower to the car, I've got these brand new Perfect Pass version 3 drive shafts. So off with the Hobeo drive cup and on with the Perfect Pass drive cup. So this is the stock spool that comes with this Hobeo car, and that fits in there. Now we do have a potential problem. So the main shaft is 8mm, and then it steps down to this, which is only 5mm. That looks really thin and liable to snap off. And on the armours, where the diff pinion comes out, that's only 5mm, and they have snapped off in the past. So Perfect Pass has made these spool shafts here, and there's 8mm all the way through. Don't forget, I'm going to put a link in the description box to all the parts that I've used in this build. Just look at how perfect all this stuff looks. Next up, we got to do the same again, but on the front end. Boom! Hold on, I've changed my mind. So I've been messing about a little bit with the layout, and this is what I've come out with. So up front, the servo fits perfectly in between the motors and the steering posts. Then we got 2 speed controllers, and then the rear motor, I've actually spun them round and put the rear motors more towards the middle. The reason behind that being is you know when you throw a dart, it kind of goes straight because it's got all the weight at the front and it's got the fins on the back. So I'm kind of thinking the same sort of design on the RC car might work better. Also, more weight on the front means less likely for air to get underneath and make the car backflip. Also, it means by having all 4 motors pointing in the same direction, they're all going to be turning in the same direction. That means all the ESCs are all going to be set up exactly the same. And there's just so much space on this chassis. So battery wise, look, if we put the battery all the way in, we've still got so much wider we can go. Height wise, we could even go double the height and still get the body on it. We've still got all this space around the ESC, so we could fit bigger motors and bigger ESCs if we have to later on. So next up, I've got to drill these motor mounts into the chassis, and then I can measure up what length centre drive shaft I need. Now I can run it as it is and have the front 2 motors front wheel drive and the rear 2 motors rear wheel drive. However, it might handle funky, so I want to have the option to be able to join the front and the rear together and have it all as one unit. A lot of you guys were curious to see how much it weighs. 16.2 kilos. We've still got a little bit more stuff to fit, like body shell and stuff. 17.3. We're probably going to be coming in at 18 kilos, I reckon, when it's all done. Right, waffle, waffle, waffle. Let's get the motor mounts mounted. So I've just set up the motor mount where it's got to go. I've used this trick coming up now from Raz Schifrin. So I'm going to get some double-sided tape and stick it to the chassis. Then we make it a little bit wet to make it less sticky, and then using our guides we can put the motor mount into position, push down on it, and hopefully where we got to drill the holes it's going to leave a mark. So now if we look here, we can see exactly where we have to drill. And then to drill it, I'm going to use this little carbon fibre drilling kit from Scorched Parts. This stuff is super itchy and bad for your lungs, so don't touch it or breathe it. Next, we need to countersink the bottom with the included countersink drill bit. Beautiful! Oh no, I've messed it up. What the hell happened here, look? I had all that perfectly square, and now look, it's just... I don't know what happened there. The whole thing's just not square anymore. It's like, what? Oh. Well, I did the Raz trick completely wrong, obviously. Don't know what to do. I can see it in the comments. He can build a full-ass monster truck, but he can't build a toy car. I know. Anyway, I know an easier way of fitting stuff, so hopefully we'll fit the rear end and this side will somehow sort itself out. Boom! Rear end fitted. Front end kind of sorted out. I drilled a new hole and didn't use the ones that were off. Rear end actually worked out perfectly. On the front end, I drilled it straight away. On the rear end, I've done it the same technique with the tape, but this time centre dotted it. So that's all 4 motors hooked up. Now, Raz Schifrin from Perfect Pass is going to make me a longer centre drive shaft. He warned me and said it's probably too long. You don't really want to go much longer than what this is. The longer you go, the more centrifugal force is going to try and make it flap in the middle. And Raz is kind of worried that if it does break, it's going to wipe out whatever's here. But these have got a metal housing, so it should be okay. So we're going to go with one long shaft first. If it does break or it flaps about, I'm going to put a bearing block in the middle and 2 shorter ones. So because we've narrowed these 2 mounts closer together, we can't put the lid back on. So we're going to need to cut these ends off, then we can put them back on. For a top brace, I'm going to use a piece of tube. We can just bolt that all the way across the top here. This one's not long enough, so we're going to get some more from eBay. And while we're waiting for that, we can crack on with some other stuff. So here I'm mounting the servo. My motors are too close together for the carbon fibre top plates, that's why I'm using tube. Next I'm going to mount the speed controllers. Now these XLX2s have got screw holes underneath that go into metal, so I think I'm just going to bolt them through the chassis. I've made this little template here, we can lay that on there, drill through, screw it on, boom, done. So now that we've got all these holes drilled, we can go ahead and put all these motors and speed controllers onto the chassis. However, I've got these diff lockers here. It's going to be easier to put them in now while it's all still lightweight. Look at the quality of this machining. Look at that, fits together absolutely perfectly. So I've put one shim on this side to tighten up the mesh a little bit. Next up, scorched rear drive shafts. Next up, I'm going to turn these little things round so that we've got 0 rear toe in. I'm not going to bother putting the rear sway bar back on because I don't think we need it. Next up, we've got the front differential, which is different for some reason. So let's get it open and have a look. I'll know a quicker way. I'm not going to bore you the same again. Right, here we go. Ready? Boom! There we go. Got it all assembled. So you actually use all the cups and everything from the old differentials. You put it all into there, and these little pins and screws hold it all into place. Look at that machining. I know I keep saying it, but lovely jubbly. The same as the back. I've added one shim to this side here. Boom! So now we can go ahead and put all the centre drive shafts and spools back in, permanently mount the motors, and screw in the ESCs. Next, we've got to mount the radio gears. I've got a receiver here and a gyro here, and I've got this box here from a Kyosho that everything's going to fit into. So we've got loads of space in the middle of the chassis there, so I think we put the box there. That's also going to be in the middle from the speed controller, so that all links. We can put receiver there, gyro there, and I'm probably going to run a Perfect Pass, so we can glue that to this side, and then there's going to be enough space to shut the lid and have all the wires inside the box. Right, change of plan. I messed up. Well, I put that box in the middle. I've forgotten about the centre drive shaft's going to go through there. The Kyosho box that I had did not fit on one side, but I found a different one here from a Hobeo, and that fits perfect. Next up, we've got to mount the lipos. So I've got these battery straps here from Scorched Parts. So I'm going to put one there, the same again, all the way along there, and then we can Velcro the batteries down, strap over the top, job done. Right, just had my tube turned up, so that is going to fit on there perfectly. I'm still waiting for the flat bar so we can mount it. So let's put this to one side for a minute, and next, let's have a look at the suspension. I'm going to try and do everything in my power to stop this car from doing a backflip. I think with it being so long, it's less likely to backflip, but if it backflip, it's going to go to the moon. If you look at David's car, air got under it, that thing went 20, 30 foot up in the air. So I think you always want the front end lower than the rear end. The minute the front end's allowed to go higher than the rear, the air gets under it and it's going to be backflipped and gone. So compared to David's car, I've got this FC100 body, what gives a little bit more downforce, I believe, over the front end. That's going to help push it down. Perfect Pass make these super extra heavy duty springs. They're more designed for like a normal Armour Limitless. This one here is like probably about double the weight. So although these are going to help, I think I'm going to go one more and put solid links in there. I'm not really sure what's going to happen. David from Scorched Parts, he's got solid links front and rear. My thinking is that if you got solid links on the front and you hit a bump, that bump might be enough to flick the car up and get air under it and make it backflip. So I'm going to try and put the Perfect Pass springs on the front, so we've still got suspension on the front, and then on the rear make it solid, and if it does hit a little stone, the suspension, it doesn't really matter too much. There's no suspension, it's going to ping the car up a little bit on the back, but that's not going to make it backflip. I've put the weight as close to the front as possible with both motors facing forwards. I've got a couple of other tricks up my sleeve to make this thing not backflip. More on that later. I think if we don't backflip and if the tyres stay on, and I've got some little tricks planned as well for the tyres, I think we're really in for a chance to win this world record. I mean, it's got enough power. We just got to make sure it doesn't backflip and blow itself to pieces. So I've taken the splitter off so that we can get to the shocks. Get the wheels on there so we can see the ride height. Oh, that was the postman. He just got us our Velcro to stick in our lipo. We've got these links here from a buggy. Hopefully we can replace them with the shocks. So that's pretty much solid now. There's still a tiny little bit of flex there. That's just a flex in the wishbone. I think that's about perfect. So here we've got the stock Hobeo spring, pretty soft. These are the Perfect Pass springs, a lot stiffer. So a Hobeo rear spring looks exactly the same length as an Armour front spring. Trouble is, the Hobeo front springs are a lot shorter. Don't know how we're going to make it work. Oh, look, now that it's off and decompressed, I think it's the same length. Please work. That's on there. And now for the other side. Boom! Got it all on there. Look at it. It's holding up all the weight now. I mean, it could still be a bit stiffer. We could probably wind that shock collar down and then limit the suspension travel with a droop screw. In all other RC cars, that's a massive no-no. It's going to make the car handle awful. But for speed running, that seems to be how people do it. But anyway, I've got these longer springs here, which are even stiffer. Let's see if we can make that fit. Boom! Oh man, got them in there. But man, that was a squeeze getting them on. But look, that suspension, I reckon, feels about perfect now. Next up, let's get the batteries mounted. I'm using this 3M dual lock stuff. Next up, we've got to stick something to the batteries. So at the moment, it's nearly 18 kilos, and that is nearly 40 pounds. Man, look at all that horsepower. I think we got the world record in the bag. Or in a bag, as Raz said. Next up, we've got to solder up all the battery connectors. So for that, I'm going to be using these Perfect Pass battery connectors. These are compatible with the QS8. Well, they actually are QS8. It's made by Perfect Pass. But look at the size of those terminals in there. If you compare that to a normal connector, what I use in my other RC cars, that's size difference. So Raz Schifrin, the owner of Perfect Pass, he actually solders his connectors on a different way. He doesn't bother with tinning. He just direct solders all the heat from the soldering iron and supposedly gets a perfect joint. So that's how I'm going to do on this one. And apparently that is a perfect joint. Next up, we've got to hook up the servo and all the receiver and the ESCs all together. Boom! Right, got it all wired up, even though it's still untidy. Still got to tidy it up, shorten all the wires. First, I've got to one by one set up each ESC. One with the colour ones to master one, so we do that one first. And then on all the other wires, once we've set them up, we've got to take away the power lead. And then hopefully it's going to work and no fires. I've had a lot of these XLX2s catch fire on me in the past, so I'm really nervous. We've got 4 of them on here, so that's like 4 times the chance of catching fire. Please don't catch fire. Hey, got Vinny in the house. Vinny wants to see it for its first fire up. We've got the fire extinguishers ready just in case. Chicken. I was going to do it outside and Vinny's like, do it in here. And we've got a sprinkler system, so...
Set it on fire. I mean, start it up, I mean.
So Raz has given me the setup procedure to set the XLX2s up. I'll have this ready. I've had so many of these things go up. I don't want to burn my shop down. You know?
Oh, come on, they fixed it.
Hopefully they fixed it.
Sure they have.
We're using Castle Motors with Castle ESCs this time with all the regulated KVs and all that, so it should be good. I'm using some different batteries just in case it does go, so I don't kill my last new Onyx batteries. I'm terrified. I told it right, haven't I? Like.
I did say that. You got to hold the throttle, turn it on.
Battery's plugged in.
Why is that one on? Oh, it's because it's getting back voltage to them all, isn't it?
Oh. Oh, that's bad.
I thought it was throttle.
Why are you still doing it? It's unplugged.
Capacitors have got voltage in them, haven't
Right, we've got to unplug all these other ones. We've got to do one by one. Well, let's unplug the other ones anyway.
they? I would.
Because you've got to do one by one. I didn't think it would matter.
Cool, we could have needed that fire extinguisher.
That's putting all that power to move the motors through these little wires. That's not good, is it? So Raz told me when calibrating the ESCs, make sure you do them one by one and have all the other ones unplugged. Otherwise you backfeed them voltage. That's what happened here. So we faffed about with it a little bit more and I think it's ready to see if it all works together with all 4 motors. So we've got it all linked up now. We've got Razzie on the phone over here, look. Hello, Raz.
Hello.
Hello, we've got Raz in the house. So Raz is helping set all this lot up. We've just gone through all the settings. We haven't tried them all together, so this is first time trying it all together.
Yeah, switch it up. You must start with a master.
Well, that was the master. He kind of just went on and off.
He's an amateur, isn't he?
No, actually, Kevin's a genius, man.
Actually, I know cool, I'm just winging it.
He just wings everything.
You can't judge a fish by its ability to climb a tree, can you, I guess? So now, I'll do master on first. And after even more faffing about, it's finally ready to see if it works.
That's it, that should all work.
Right, here we go. That's like quarter. Next, we got to put all the drive shafts back in, get the spur gears back in, and then we can take it up for a little blast. Bye, Raz.
Bye.
I think we're ready to take it out for its first little test drive. So I'm going to take the foam tyres off and put these tyres on just for the first run. I don't want to kill these ones. There we go, ready for its first run. Next video, we're going to completely finish it off. We still got to put this top brace on. I've got a special trick up my sleeve to try and make these tyres hold up a little bit better. So far, everyone going for a world record attempt, the foams are coming off. We've got to paint the body, and if anything goes wrong now, then we're going to have to fix that too. And then, in that same video, the next video is going to be the world record attempt. Right, let's go out for its maiden voyage. So I've just set up the failsafe. The idea of the failsafe is that if the radio loses signal, it puts the brakes on the motors. But I want to make sure I set it up right, because if I've set it up wrong, it's going to be giving us full throttle. So I've taken the wheels off just to make sure that it all works. Radio on. Now we've got to turn this off. This is where it might go flat out and blow up. Bit's going to fly if it goes flat out.
Where to stand?
I don't know. I'm going to stand here.
It's in full shot.
I'll stand behind ready.
Are the brakes on?
Yep, all red. All
Is
red.
that brakes on?
Yeah, all red.
That's making brake noise, isn't it?
Yeah.
Right,
There you
brakes
go.
on, right.
There.
Alright, we're good. So with the failsafe working, we can now put the wheels back on and take it for its first run. No.
It's got suspension on the front.
That weighs more than I do.
Let's have a look at the chassis. Look at that. That is a beaut. I don't think that's going to be. I don't think that's going to be like that when it's finished, is it?
No, we're only going slow. So where the car is so long, the turning circle is horrendous. I'm literally giving it like no power at all there.
The old brakes are noisy, aren't they?
About 70 mile an hour. Wow. Not even trying. I was just trying to make it not go fast. I've got the record in the bag, or the car's going to be in the bag.
Come on, let's have a look at the chassis.
I think our biggest issue is going to get the tyres to stay on the rims. Once you start getting close to the 200 mile an hour mark, this can happen. And that can make the car crash. But I've got a couple of tricks up my sleeve that I want to try out. More on that later. But for now, let's get this car finished. So first of all, let's get the body painted. Now this body's in 3 sections. I cut a stock Delta Plastics FC100 body in half, added a bit in. So we've got to take it apart, paint it, I think in my legendary red, because why not? That's my colour. So let's take the body all apart again, paint it, then join it all back together again permanently, and then it's ready to fit. Check this out, guys. This is a Perfect Pass custom-made drive shaft that is to join the front and the rear together. Massive shout out from Raz at Perfect Pass for getting me this made. It's crazy long. Look at the length of it compared to a stock one. Almost double. And Raz was kind of concerned that over this sort of length, it may flap. But man, this thing feels super sturdy. I don't think this is going to flap about at all. So there we've got the body all riveted together. I've also put these sides on here. I didn't bother filming it. It's just a bit of flat bar and I've screwed it in from the bottom. Also, I put a couple of body posts here and here. Idea is the body sits in there behind it and it's going to keep it nice and tight. We're not going to need to put any tape on there or anything to hold it down. Once we've got the body clips in there, that is solid. Also, we usually run tape across the front to stop air getting in. I want to try and make it more user-friendly. I've put these pins there. We put the clips in there. Hopefully, that's going to pin it all together so we don't need any tape anywhere because we put the body on and go rip. So with these sides on here, the chassis flex has really reduced, and with the body on, the flex has almost gone all together. But I want to make it even more rigid. So I've got this tube here to put across the middle and a couple of bits of flat plate to bolt it on. Then I'm going to get this tube and I think just weld it on the top of that. Then I've just got to do something to the end of the tube to make it a little bit nicer. Next up, wheels. So most people run these wheels at about this size. I've got a tyre truer here so you can make them smaller. So I've tried to make them this size because when you get in near 200 miles an hour, this foam just tends to fly off of the tyres. So my theory is less foam, less centrifugal force trying to pull it off. Maybe it's going to be more reliable. But on the flip side, because the wheels are smaller, we've got to gear the car higher, which means the wheels are going to be spinning faster. So maybe it's going to be worse. I don't know, but I'm going to give it a go. Also, I am doing everything in my power to make this car not backflip. So if air gets underneath the front too much, it's going to lift the front up and it's going to backflip. These tyres, if you look at the bottom of the tyres, if the air hits that, it's going to try and make it lift. So I'm going to try and narrow these and make them a little bit thinner. Hopefully that's going to help it not backflip. So you put the tyre on there. When you switch it on, that spins round, you move this along, and that's what turns down the tyre. However, I want to do it this way, and the only way that I think could work is maybe grind it as it's going round. Might work, might not. That's how wide it was, and that is how much has come off. Let's try a coarser one. Boom! Well, it worked. That's how wide it was before. There we go, all fitted, and also we get a lot more steering now. Look at that. I've been doing a little bit of work off camera. I didn't want to bore you all. You guys all want to see this thing rip. I've wired all the switches from all 4 ESCs all the way to the back here, look. So when we're on the runway, instead of holding everybody up and having to put all the plugs in and then all the switches on and the body on and then whatever else you got to do, all I can do, put it on the track, hit the switches, go rip. Not the neatest, but function over beauty. I think we're pretty much good to go. We just need some game over stickers. We are ready for action. There's like no flex in that chassis at all. This thing is solid. Man, this thing weighs an absolute ton. Man, if these tyres hold up, I reckon we might have the record in the bag. If the tyres don't hold up, then the car might end up in a bag. That's what Raz said anyway. Oh, look, just a last minute little upgrade just turned up. So these stock little arms on here, it makes the rear wing really floppy, look. So GPM make these ones here made out of aluminium. Let's get them on there, see how it looks. Boom! Check it out, got them all mounted. That wing is so much more solid now. Last thing we want when we're going over 200 miles an hour is this thing to start getting the wobble on. So here, I just want to plug it all in, rev it all up together, make sure that the centre drive shaft is going to stay straight at all these RPMs. Raz did warn me that a drive shaft that long, that once the RPMs get up, it could start flapping about. So let's see what happens. Ready?
Yeah.
Yep, unfortunately, Raz was right. The drive shaft was flapping about and rubbing on the motor, so we're just going to take it out and run it with the front and rear separate drive. Oh my God, weather is... Man, I hope this weather gets better soon. So we got the speed sausage out, and everybody is admiring the sausage. What do you all reckon? Are you all impressed about the sausage?
I think you've got an impressive sausage, Kev.
Oh, yeah? Yeah.
It's got some good girth on your sausage as well.
Okay, we've got all these YouTubers lined up everywhere.
Beautiful.
Go on and get the lid off, have a little look.
Men to take the top off the sausage. Oh!
There's about 100 horsepower in there.
Look, you've got Raz. Bit of Raz.
So I didn't want to waste any time, and I took my car out in the wet to get the tracking done, make sure it went in a straight line, make sure it all worked. But bad idea because it completely got drenched. We are off. Hopefully tomorrow we got better weather. So back at the Airbnb, a little bit of maintenance. Our servo saver is super weak. We can't really adjust it very easily, so I'm just going to take it apart, try and jam it up somehow, and hopefully we can have steering. Oh, Jesus, that's tight. Man, why won't that move? So there we go, got it tightened up all the way. So now what we've got to do, put it back together. Boom! Day number 2, it looks like it has been raining overnight, but it's stopped now. Hopefully, it's going to dry out. Oh, look, got some blue sky coming. Back on location. Look at that smooth runway. Hopefully, we're going to get this record in the bag. Look at it, perfectly dry. Yes! Sausage nearly ready to run. Here, we've got all my lipos charging. So 8 of these Onyx lipos all to go into that sausage. This thing weighs a ton. Ugh. So we're going to do a quick shakedown run first. I want to make sure it drives straight. I want to make sure we got range. I want to make sure that we can turn it around on the runway. Then we're going to get it back. I've got some old tyres on it in a minute. Put the real tyres on. Then we're going to charge it up. Let it go rip. Hopefully we've got a chance against Dave. I don't know what's going to happen. No, absolutely no idea. What do you lot reckon is going to happen?
I reckon one first proper run it will do easily 190.
Easy?
Easy, yeah. Easy 190. Then probably 200 and more if you slightly change the gear. Hang on, what's it geared for at the moment? 250?
250 the gearing. Tyres will probably blow off before that.
It's definitely going to do 200.
Hopefully my little tyre trick is going to work.
This is a test run, yes?
Yeah.
What we're going to go for? 100 miles an hour?
Yeah, just anything. Might be 100. Nothing too spectacular. Quick little, just nice little, get the trim right, see how far it can go. Little range check.
Wow. Wow. Quarter throttle.
139.29 both traps.
139 at quarter throttle.
Doing something weird.
139 on both traps.
Nah, that wasn't bad for not trying.
Yeah, that was absolutely flying.
I don't know what it was doing though. It looked like it started going funny. So the car's come back. What? Is this going to be bad? You're worrying me. Oh. So that wheel's gone. So all the foam has come off, but they were wet. So we're going to put the Gone Bananas on there. I don't know if the thin tyres is good or not, but that's what we're experimenting.
Yeah, man, to the moon.
Look at that, all come off. Hopefully these skimmed down tyres are going to last. Otherwise, we have to leave more rubber on there and then it might blow off. No idea. All a learning curve, we're all learning. Battery's back on charge. Here we go. We're going to see how it feels. If it feels good, we're going to get on the power. World record, maybe. Who knows? We'll give it a go. Here we go. 225 mile an hour.
All right.
Probably not. Probably big crash.
Yeah.
Oh, nowhere near full though.
I think you might need to take a bit more run up. Whoa.
Yeah, they've all gone again.
Oh my god. Yeah, look, all the foam's done on it.
We need a perfect pass on it. So all the foams are completely off. I've got some more tyres that are like with not much foam on them. Another problem, this car's got no perfect pass on it. So I'm trying to pull the trigger really smoothly to get the power in. But then you get to the end of the run and you're like nowhere near full. So I haven't got any perfect passes, but Chris, all the way over there somewhere, lent me this, which is a FlySky Noble, but this has got a servo delay built into it, so we can make the servo delay up to 20 seconds. So we set it to about 8 seconds, 10 seconds. We can get to the end of the runway, full power, just hold it there, and it will progressively, smoothly put the power in until we get flat out at the end. So out with the Futaba, in with the FlySky. Boom! All wired up to this now. We've got the new radio on there. We've got a 10-second delay, so we can literally get on it, pin it full speed, just let the thing rip, see what happens. If tyres hold, great, maybe world record. If they don't, might be no more sausage.
Here we go.
Oh, tyre. 157. That looked a lot faster. Oh. There's nothing left.
What? How? How did that even get back? Oh, poor chassis. So what was the speed?
158, I think it was.
Was that it? Oh my god, look, the remains of the tyre is inside here. Well, this is actually the wheel. I think that was 158 mile an hour. It blew before it got to the traps. Somehow kept it together to not crash into the traps. So we're going to try another set of tyres and more foam on it this time and see if they last. But trouble is more foam, more to pull the foam off. I'm truing up some tyres, but this time I'm going to leave a little bit more rubber on there. On the front one, I still want to try and make him a little bit narrower. Standard width and narrowed. My idea of the narrow is because you see where it's got all this here, where it hasn't got any strengthening, it's really flexy. So having it like that, it's a lot more rigid. And also, because these are the front ones, the air gets under it and tries to make the car backflip. So the narrower, the less likely to backflip. So it might work, it might not. We'll see in a minute. Cut! Here we go, keep out of the way everyone. I don't know what else can happen.
Oh no! Oh no!
Tumble, what happened? Game over. I don't
Oh.
know how fast it went. What's it look like?
It's absolutely fine. Split is bent. It's all good.
Oh, not too bad, is it?
Yeah, it's fine.
Oh. Oh, I completely ate these. 193 on the GPS. Could have been a lot worse. I'm happy with that. I'll take that. We're going to come up with a new tyre idea. We've got a couple of tricks up our sleeves. What happens? So what's interesting is that these tyres here, we slimmed them right down and they survived. The back ones were wider and they're gone. So maybe we wanted something with slimmer, maybe. But look at this in there, look at that.
Done some gardening. Everything else is alright, isn't it?
I thought our vision of the whole thing just toast, like 3-week build out the down the pan. You hungry?
You snap that one in half.
Oh!
Dunk it, I couldn't where it's hit the...
So the reason for this drive shaft breaking is where it hit.
Well, it looks like it's flexed and it's punched the bolts out the back of the bulkhead here, look.
Yeah, that's come off. So
Bent that one as
the
well.
whole front must have gone ooh and took the shaft out. So Andy's got his laptop, he's going to plug it into the speed controller and check out the logs. So these can take, I don't know about all these amps and volts and everything, so Andy's going to explain, but I think these can take 700 amps, is that right?
Yeah, 700.
So these can take 700, so if that was pulling less amps, that means we have loads more power in it, is that right?
Correct.
Right, and then with the battery's voltage?
As long as it's, obviously the higher it is, the better.
Yes, the higher the voltage, so what is a good level for voltage?
28?
28, right, okay, let's plug it in, see what happens. So I plugged it in, but I don't know what I'm doing and forgot to clear the log, so that's from yesterday. But that means nothing to me, all that lot.
204 amps, 31,703 RPM.
So what's that telling us?
So the back ESC is telling us at the peak we were drawing 247 amps.
So
which
50
is
more amps.
50 more amps to the rear, 46,000 RPM, which is 15,000 RPM more than the front.
Foam tyres just will not hold up. As soon as you get anywhere near 200 mile an hour, the foam comes off down to the plastic. But I may have a possible solution. In that box there, I've got some special tyres made by a certain company that I can't really mention yet. So I'm going to test those out. I think they're going to go a lot faster. And over there is a prototype wheel that I'm working on myself that also might work or might not work. I also know of a couple of other people that are working on some new tyre and wheel designs. So once we get the tyre and wheel issues sorted, I think this car's definitely got 250 mile an hour in it. It's got so much horsepower. It's got so much more to give. We just need tyres that hold up. I'm also going to put the centre drive shaft back in. If we looked at those logs and also the fact that the back tyres were completely gone and the front tyre survived, the back was completely wheel spinning that burnt all of the foam off of the tyres. If we link the front and the rear motors together, then we should eliminate that problem. What I'm going to do is, like on David's car, we're going to put a bearing block in the middle and we have two shorter shafts. That way, all joined together, shorter shafts, it's not going to flap about. Steering wise, this plastic steering here was super floppy. When it was rearing off into the grass, I was full steering and this steering was so spongy I just could not steer it. So I hopefully David from Scorched Parts is going to make an aluminium servo saver delete kit that's going to give us much better steering. We're going to try and come up with a tyre that can take over 250 mile an hour. A lot of people in the last video says, why don't you use rubber tyres? Well, a rubber tyre is a lot heavier, centrifugal force is a lot greater. These can only take about 150 mile an hour before they go pop. So far, the world's fastest RC car has gone over 220 mile an hour, and that was using foam tyres. So up until this point here, foam is the way to go. But with these speeds that we're trying to get now, even the foam will not hold up. So let's have a little mess about and see what we can come up with. And then we're going to take the car out again and see how fast it can go. So here, I've built myself a tyre dyno. It's just a motor, direct drive, straight to the wheel. We're going to spin this up. We've got an RPM counter here that says on the screen here how fast the tyre is spinning. We're going to see which tyre design can spin the fastest. And then we can measure the tyre diameter. Look on here what the RPM is. Put those details into the computer, and then there is going to tell us how fast the car is going to go. Now, bear in mind, there is no load actually on the tyre pushing it down onto the road, so the results maybe not that accurate, but at least we can see how fast a foam tyre can go. Then I can come up with my own tyre design and see how fast that can go, and if it goes more than the foam tyre, then in theory the car should go faster. Now in future we could always add a roller to the bottom of there pushing onto the tyre to simulate the road, but for now we're just going to run it like this. So first of all, I'm going to run a contact foam, then we're going to try Gone Bananas, which is regarded as the best foams in the industry. I've got some Gone Banana prototypes here that apparently are going to go a lot faster. I've only got 4 though, so I don't really want to blow them. And then here I've got my own tyre design, which is a little bit secret, so we're going to try that on there too. I'm really hoping that this tyre design here is really going to go over that 250 mile an hour mark. So here we go, contact foam first. So I've got this contraption here controlled by RC so I can get myself out of the room into safety. Check this out. Look how much that is expanding just from a little bit of throttle. So we've got a camera there seeing what the RPM is and what that is doing. Another camera there so we can get a side-on profile. Let's see what happens. Right, here we go, here we go. terrifying. Look at that, it's all gone. Let's check it out in slow-mo. So that was about 23,000 RPM. We put that into the computer. 23,000 RPM, 100mm tyre. Wow. That is 269 mile per hour. Now we know in the real world, once there's load on the tyre, the contact foams, what I've been told by other people, they can last up to about 170, 180 mile an hour. Next up, let's try a Gone Banana, same diameter. Boom! Oh my god, that destroyed my rig! What? Oh my god! That ripped the whole... What? Jesus, look at that! They ripped apart the whole entire wheel! What? So I made that about 43,000 RPMs. That works out at 504 miles per hour. Look at that, where this tyre blew, a piece of it must have come off and hit up here. Look at that. It dented that hose up there, and a bit of the plastic of it has ended up here. That's all for my sprinkler system. Hopefully it's not going to set it off later. I'll tell you what was amazing though, is how far out this wheel was coning. I couldn't believe when I watched the slow motion that this came to about here. I mean, I'm surprised that foam even stayed on as well as it did. So what's making it come off must be like the combined G-force pulling it off and the abrasion of like the floor. So I don't know, mad, crazy. Anyway, broke me dyno, so I've got to put a new link on there and then we'll be back in action. Boom! Back in action. Now, if you remember back on the video where I ran this car, I experimented with narrower tyres to sort of limit this action from happening and also less foam on there. Like I turned it down this way, making the tyre smaller. 91mm, normally we run these at about 100mm. My idea was, let's wait to try and pull it all off. So let's chuck this on the rig and see what happens. The motor actually ran out of power. I'll just reset it to ESC. We're going to get on it a bit quicker just to see what happens, but it seems to be holding it a lot better. That took it flat out. So the memory on here says 45,000 RPM. Next up, I want to try my prototype. Right, let's see what this puppy's made of. Right, here we go. That took maximum RPM and it looks kind of intact. Guys, it's intact. The motor got to full RPM. It didn't blow. Could be onto something. So this time it only revved to 23,000 RPM. I think what was happening, I did not balance that wheel. It was shaking so much it made the ESC cut out. But still, 23,000 RPM on a 106mm tyre, that equals 285 miles per hour. So fingers crossed, I'm really hoping it's going to hold up and we're going to get that 250 mile an hour goal and smash the world record. So now, just out of curiosity, let's see how fast some stock rubber infraction wheels can go. Right, here we go. This is going to be violent. That sounded nasty. So 12,000 RPMs, that works out 140 mile an hour. That's pretty much bang on. So my homemade tyre did 23,000 RPM, which is actually way less than the 45,000 RPM on the Gone Banana. I think what's happening, the vibration of this was shaking this whole rig, zapping the power, making the ESC cut out. So over here, we've got a prop balancer. You can put a wheel on there as well. Perfectly balanced the wheel. Just chuck that on there, balance it. We've got that on there. And what we've got to do is wait for it to stop. And then wherever it goes to the bottom, that's where the heavy bit is, and we add weight at the top. I'm sorry about blurring out the tyre. It's my own design. I don't really want other speedrunners to find out yet what I'm doing. Because I'm going after a world record, I wouldn't want someone to then get my idea, and then make the bar even higher, make it even more difficult for me to get. Once I've got the record, then I don't really mind if someone else gets it. But for now, I want to at least once say that I've had the world record at one point in time, even if it's only for 30 seconds. So normally to balance, we use this pate stuff like we have on this one here. However, with the RPM, look at that. It's all starting to come off. So I'm going to try to do it with hot glue. So up here is where the wheel was the lightest. So I was going to go ahead and just squeeze a little bit of hot glue right there in the corner. Hopefully it's going to stick. Back on the balancer. And we need a bit more. And then we keep doing that until it stops spinning. Right, there we go. It stopped spinning. It's not perfect, but it's a lot better. All right, here we go. All balanced up. Maximum RPM. No idea what's going to happen. Hopefully, it's not going to hit the sprinkler system we got up there. Oh my God, it did actually finally come off. So what happened there, on the first attempt, the ESC cut out again. There's probably still a bit of vibration there. So the second attempt, I really went for it and it got to only 15,000 RPM on the reader. I think it went a lot more because we got on it so quick and this just didn't pick it up quick enough. Anyway, I think it's going to hold up. We're going to try it out on that, I think. A few days later, look what just showed up. David at Scorched Parts don't mess about. We got the aluminium servo saver delete kit. Let's get it on there. So this stock unit has got so much flex in there, it made the steering awful, especially for a car this heavy. So this should fix it. Man, that is perfectly smooth, zero slop. There's little ball bearings in there. Next up, we've got to fit a new splitter. The next problem that we had is that the hexes were stripping out of the wheels. This thing has so much horsepower that once the power kicked in, it just stripped the hexes right off. So M2C Racing has this solution. So let's fit it on there and I'll show you how it works. Next up, we got these little drilling jigs. That goes inside your wheel. And this piece locates into here. Bolt in the middle to hold it. Then with the kit comes a drill bit. And now look, there's no way that that is ever going to strip off ever again. Yes! Postman just turned up. So a couple of diversion 3 drive shafts from Perfect Pass. They're bigger pins, bigger ball, bigger diameter shaft, Perfect Pass ball shaft. Then here I've got a bearing block mount thing from Scorched Parts. It's actually this piece here from the motor mount, but 2 of them. So the idea is one this side, and then this all mounts in the middle here. And now, instead of having one long shaft that's going to flap about, we've got 2 shorter ones. Also, check this out. These are some aluminium knuckles from Scorched Parts. Just check out that quality. These are actually for Armour Limitless, but I'm going to retrofit them onto this VTE2. On the stock Armour ones, these always come loose and it all flops about. Scorched, they make everything so there's zero slop and everything moves perfectly freely. Also, check it out in there. Look, much bigger bearing. This inner bearing on the Armours often fails. On the stock Armour ones, you always round off that Allen key in there. So the Scorched ones come with a much bigger one that really locks in there tightly. The other good thing with these is you can adjust your camber by putting a wrench onto there. When you've got your wheel on there, it's impossible to get to it to do your camber. So this makes it a lot easier. So on the actual Scorched Parts, there is no slop at all. But if we look at this link here, look, it's got a little bit of play. So we've got to fix that a bit later too. So here's how the centre drive shaft setup's going to look. So all we've got to do, drill it into the chassis, put the cover back on, boom. There we go, we've got the whole 4-wheel drive system working. Here we are, Redfin models. We've got Jason and Chris in the house. So we've got the speed sausage and Redfin models at the minute. Chris has just helped me set up a radio. We've just tried to calibrate. This ESC appears to be dead. It's not really driving that motor. So when we did that speed run, did 193 mile an hour, the back wheels were wheel spinning and the front wheels weren't. So your theory is?
I think that ESC's dead, or almost dead. Very low output, yeah.
It beeps really quietly and it barely drives the motor, and sometimes not at all. So we did 193 mile an hour with double the power going to the back wheels. How fast do you reckon it's going to go with all 4 motors working properly?
When we get out, that's the thing.
It might be more stable.
Yeah.
Right, anyway, we're going to put a new ESC in there, get this thing calibrated. Here we are back in the shop, new speed controller. Let's get it fitted and unleash the full 100 horsepower. Oh no, I rounded it off. Oh, and that one, and that one. Oh, anyway, no big deal. We have this. We've got to do now is change the connectors over, install it, calibrate it. So the quickest way to get these on there. Boom! There we go. Back in action. So Max is just plugging in all the lipos, and then we're going to see if it works. We got that ready because, you know, we've had a few fires with these already. Hopefully not again today. Master ESC on first. Then we can turn on all the other ones. So now we pull that trigger and all those pinion gears should all turn. So now we're going to mesh them all in and just make sure that they all turn nicely together. There we go, we can see the temperature drive shaft all working. All the top shaft lovely and straight. That was about half throttle. So that's that car ready to go. Hopefully, I've been speaking with Santa Pod, we can take it there to run it down their drag strip. So now with all 4 motors working, better wheels, the front and the rear end all connected, hopefully we're going to get that record. I'm going to give it a quick run on the prototype tyres to make sure it tracks straight. And then we're going to put on the Gone Banana prototypes and proper go for it.
He's not been speedrunning that long. I think Kev's been doing it. This is his 2nd year.
We're not proper going for it yet, I just want to make sure the track is right. So that was just a quick warm-up pass. The next, a little bit more power.
You said there's no throttle?
There was no throttle at all.
Oh no! Oh no! Oh no!
So playing it back in slow motion, it looks like there's bits of tyre coming off and then a whole entire wheel.
Wheels off.
It did kiss the barrier, but I think it might be alright. I was there.
Well, how did you go this far?
I really hope it's alright so we can get to run it again. Oh, the tyre's gone. Oh. It car looks alright-ish. That's just come off. They've all come off, actually. Oh, something's... Oh, that's... Oh, bits are falling off inside. The whole lot's gone. Where's the wheel gone?
I saw it bounce off like halfway down. So I reckon it's in along there somewhere. Oh, it's there. Just over.
Come off from there. So we've just driven down the strip, all the way from over there, and that's where the wheel's gone. But the wheel come off around here, it crashed into the wall, and it still made it with my brakes on all the way from there, all the way down there where that windmill is. So Dave is finding bits of wheel. Oh my God, it's just exploded. Look, it's literally everywhere.
Read.
I reckon 150. Well, 140, is that it?
Exploded at 140, you're not happy, Kev?
No. I really had high hopes for them tyres.
Man. Oh well, fix it, foam, send it.
Yeah.
Yep.
Let's have a look in here. Hopefully, everything else has survived. Or it might be game over for the day. We might be able to fix it. I have got a complete spare car in parts. Oh my God, look at that!
Oh!
Look at that!
You brought half the food back of you. Look, there's these...
Oh, we got that. All right, cool.
Then we've got the out cup there.
I think we can fix it and go again.
Yeah, it's fine.
We'll get it back in action and we'll go for round 2 on the foams.
Some foams now. A bit of Kev's breakfast in there.
We've got all the parts, I think. Toby's just pulling that screw out for me because I don't get it up too tight. So we got the shaft, we got the pin, we got this piece. The arm's all right. So literally all we got to do is get the pin back in there. New hub, back in action. So if you look in here, look, that pin in that side's come out. This little plastic spacer pill thing, whatever it's called, that one's gone. This one here is quite worn out. I think what happened is when these tyres blew, the vibration of it just shook it so hard, it just done that. Luckily, I've got a complete spare car, so we can pinch all the bits off of that. We've just got to put this thing here back on. Yeah. Put a new hub on there, and we're back in action. There we go, all back in action, all repaired. All we got to do now, charge the batteries. While that's going on, we'll put the wheels on. These are the ones that I think Dave, did you get the world record on these? Yep. Yeah, so we've got a chance. We've still got a chance. Oh, yeah. These were the top secret tyres, however, they didn't work, so they're not really secret anymore. All it was a truggy rim, shaved down, and armour infraction tyre stretched over and glued on. This here's the main quarter-mile drag strip, and this is made from this prep surface. It's really super sticky, designed to make the dragster tyres stick to it. And here's a bit of a gap, and that's for expansion. As this stretches and expands, it's got to allow for the gap here. But I'm not sure if the RC cars are going to like going over it. So we're starting from here. We've literally got about half a mile over that way. But it might not be quite enough. So what I'm thinking, if I start more down this way, if you're going fast enough, it's just going to kind of skim over the top and you won't even notice. But it might not, it might dig in. I don't know. Let's see what happens.
Ooh. Rolling!
I can see dust.
Just look at the marks it left. It did not spin once. It just went for it.
It just went like, ooh, went all weird, and then I lost all the brakes, lost all the power, lost all everything. It's not, it lost drive. Where is it?
Come on, Kev.
There's a big blue movement. It's there. It's not that far.
What?
Oh, yes.
No, look, that tyre's gone.
Oh yeah, that one's
Oh,
stripped.
hold on.
Yeah, you've lost drive.
Lost drive. Oh, it lost drive on all of it.
Lost drive.
I wonder what it lost drive on. 137. We've had drive failure. It cut out halfway down the strip, and it was just coasting. No brakes, no nothing.
What did you think when he was going down there?
I thought we've lost power, so then I hit the brakes, and there's no brakes. It just coasted the whole way.
How far did it end up in the field?
Quite far.
So that grub screw's either come loose or it's done the rear diff.
I'd say check that grub screw first, make sure it's tight.
Yeah, she's tight.
Ah, it's done the rear diff then.
So that's something in the diff then.
And then, oh dear.
Oh, the front.
I don't know if this was crash though.
No, that's why I was still driving.
I don't know if that's crash or if that's why.
But why did that broken when you crashed?
Oh, we done it before it folds.
But surely these ones would have gone, wouldn't they?
Not necessarily.
Nothing major.
On the good note, there's not much damage. It's literally just that splitter. All the foam's off of that tyre. So I reckon what happened is we lost drive to the back. The front tyre started wheel spinning. And then
overspun that.
I don't know if this broke off in use or if it broke from the crash, I don't know. So looking back at the footage again, the car was hopping and skipping all over the place. That must put a massive amount of load all through the differentials and through the drive shafts. So I think what happened was the rear diff blew out first. That sent all the drive to the front wheels, and then that stripped all the foam off of the tyres, and then it overspun the drive shafts and the front drive shaft broke. Now I'm not sure, this drive shaft might have been weakened from the crash before. So now let's see that again without me waffling. So let me know in the comments, guys, what do you reckon? Do you reckon this is what happened? So going forward, what have we learned? I don't know really, but we didn't get the record. I think it's pretty safe to say that all that power and all that bouncing and hopping is what blew that rear differential out. I think also getting some aluminium diff casings is definitely going to help hold those differentials together. So they do make some for this Hobeo, so I think we're going to fit some. On the rear, I've got no suspensions. There's these solid links here, and the only bit of travel that there is to flex inside that arm. Maybe that flex, maybe that's what's making it bounce. Maybe we can put a shock absorber on this part of the arm and attach it where it normally goes, but leave the solid link on there as well, because there is some movement. And if we can just dampen it a little bit, maybe it's enough. I don't want to get rid of these, because if these are too soft and you've got suspension there, this car is so heavy, if that back end squats down lower than the front, then that means it's going to backflip. Carbon fibre drive shaft wires, I'm going to give them another chance. I know these can hold an insane amount of power, especially these bigger latest version ones, and you know, there was a possibility that when I crashed it flexed and it sort of crushed this, put a crack in it, then that's what weakened it. Or maybe there was a bit of stone left in there from all that debris that was in there that was rubbing on there. Who knows, maybe it was a faulty one, but I think I'm going to try one again. All the other shafts in there held up perfectly. This scorched part servo saver delete system massively helped this car. The wheel wires, we have to think of something. A lot of you guys in the comments in that last video where we tested the speed of these wheels, you guys were saying, Kev, you've got to use aluminium wheels. The trouble is with aluminium wheels, or aluminum for you Americans, is that the glue does not really stick to them. Maybe there is a glue that does stick, but I don't know. But all the glues that I've ever tried sticking to aluminium, it doesn't stick. And also, I would have to get the wheels custom made. So if that's what I've got to do, that's what I've got to do. But I'm kind of thinking I want to go more towards the carbon fibre wheel route, because I think they're going to be maybe easier to make. I don't know, but definitely the tyres are going to glue a lot better to that carbon fibre. Here we go, let's fix it, modify it and take it out again for another speed run. Next up, let's get the rear differential out. Oh, look, we can see a problem. Look at all those iron filings where the diff was. And if we have a look in here, the main crown wheel actually looks perfect, but then look a bit further down, the pinion completely stripped. My theory there is that because this diff housing's made of plastic, all that 100 horsepower going through it, it's making it all flex and making that pinion gear move away from the crown wheel. So, over here, I've got some aluminium gearboxes. So this should have zero flex, so hopefully that is not going to happen again. Look at that, completely stripped off. Surprisingly, the crown wheel looks perfect. But I'm not going to take any chances, so we're going to fix it properly. So in this box here, I've got a complete donor car all in bits. And here, we've got a spare differential unit. And the quickest way that I know how to get that out... Boom! There we go, here's the parts that we need. And now all we got to do is get this onto here. Boom! And now, we've just got to get it into the diff housing. So now that we've got it together, we can set the gear mesh. Now, if I move this side to side, it's got some play there. You probably can't see that on camera. We really want minimum play there so that that gear's got the best chance. We can take it apart again. In the packet comes some more shims. It's already got one on there, so I'm going to go ahead and add another one. Still some play there. Maybe another one. It's probably borderline, possibly too tight, but I think it's going to bed in. Beautiful. Next up, grease. And now we can get all this lot back together again. Or not. No, these bulkheads are different. So it appears that these are for a different car, because look, in the stock one, the shock tower fits over. Then you look at the new aluminium one, it doesn't line up. Oh, and we're running out of time. Ross is in the next few days. So I'm going to have to put the plastic ones back on, but shim it really tight and hope that it's not going to strip again. Man, I was all excited about getting these on there. Oh well, never mind. Boom. Right, got it back on there. Meshed it quite tightly. Hopefully it's going to last. Almost ready to put this back into there, but first we've got to clean off all this swarf. Look at all that, that's all the old gears. Don't want it going into the new gears. Brake cleaner. Beautiful. Next up, I've got a brand new perfect pass drive shaft to put in there. These are carbon fibre, super lightweight, super strong. They don't flap about in there. However, when you crash, it's carbon fibre so you can break them. Hopefully, we're not going to crash this time. Crashing gets expensive. So that is pretty much ready to go now. I'll need to get some more of these tyres. These are made by Gone Bananas, and these are actually a lot bigger than what most people run. These are actually truggy tyres, and they're really hard to get hold of. I've got some more coming. Hopefully they're going to come in time. Otherwise, I don't know. So it's getting close to the Rosser event now. It's been a few weeks since I last filmed because I thought the car was ready. However, it isn't now. So a bit of a waffle coming up now, but you know how I said we converted this car to run on these truggy sized foams? So this is a buggy size wheel, and this is what most speed runners use. This wheel here is designed for a truggy, but it's got foams on there, so it is quite a bit bigger. It might not look like much, but there is a difference. The offset's a lot wider, it's taller. I had to make a lot of adaptations to this car to get these wheels to fit. Gone Bananas actually sent me these just to test out as a prototype to see how we get on. So loads of work on the car to make them fit. I had to cut the body out to make it work. I had to cut the chassis out to make it work. I fitted loads of parts from different cars to make the car narrower, because these being truggy wheels, the offset's a lot wider. They were sticking out like this. I had to do loads of work to get these wheels to sit inside the car. We had to mess about with the gearing for the different radius. Anyway, I had more of these tyres ordered, and they did kind of say they're going to get them ready for the event. Now we're getting close to the event, they can't supply the wheels, and no other company makes them. So the only option is to go back to the buggy wheels. But anyway, now if we go back to put a buggy wheel on, well, I've narrowed it. It's rubbing on the chassis. I haven't got my tools here to grind it, so let's see what Rob, RC Man's got. So here we are on the Isle of Man TT start line. I'm just filming a video about that at the moment. Here we are, Studio RC Man.
How's it going?
Good. Well, no, not good actually. Thought the sausage was ready. However, we got let down severely.
Big time. Yeah, Gone Bananas, unfortunately.
We were promised wheels. They never showed up. So now we've done all this work for nothing, and now we've got to do more work for nothing.
So we're going to have to use normal wheels, mate. Dremel's coming out.
There we go. Boom. What do you do, Rob?
This is sticking out and this is touching the wheel, so it's got to get rid of it. Sorry, Raz.
So with the wheel on there, look how close it is to there. And that is because I made it 0, so the wheels are straight, and it brought it back and it's rubbing on there. Bye-bye. So there we go. Look at all that clearance we got now, so the wheel won't rub. Next thing, if you remember at Santa Pod, it was bouncing. And we've got solid links here, but we've got all the flex in the arm. So I'm thinking, we get a shock, just bolt that in there, hopefully just take that hop out of it. So there we go, that's all on there. So now look, little bit of flex there. Should hopefully take that oscillation out of it. Oh, what's this?
A light? I made you a light. Check it out, and look what it does.
And a camera.
It holds the camera, look. Boom.
You guys said you wanted to see onboard footage. Now, hopefully we can.
Look. Boom.
Boom. Got these M2C little wheel hex things on there, because these hexes always strip out when you've got loads of horsepower.
Oh, Kevy. I've got some special wheels for you.
Are they top secret?
They are top secret, but I'm just going to give them a glimpse. So they're just standard BSRs.
Yeah.
200, but carbon fibre rings.
Ooh.
They look a little bit messy because that's the first time I did it. But
Because the big problem we have is these expand into a big cone.
so I can show you. So, okay.
Yeah.
And now,
Oh.
and also when this expands, but now watch.
Well, I've done the video before and it literally expands to there.
That's right, but now I've tested these to 33,000 RPM, and that's when they explode. Now 33,000 RPM is 280 mile an hour.
The goal for me is 250.
Oh, mate, they're going to hold up. You got it in the bag.
I can't get too excited just yet, but hopefully.
Yeah, like.
I'll tell you what is in the bag.
You were going to say that. I knew it. I was like, he's so good at them.
Next up, a little bit of wheel balancing. So we got a bit of this pate stuff that we put it in so that it balances up. There's one we did earlier. So we got all the batteries plugged in. So we've got to see if it works now. Go on, give it a rev.
85%.
35%?
Yeah, did you hear it?
Do 45%.
Okay.
So 40.
Are you
It's
sure?
45.
Okay, here we go.
100?
No! Yeah, we could do like maybe 50.
50.
Really? Are you okay over there?
I don't know. 100 horsepower here. We've got a possible solution to speed running tyres. Foams always blow off. This company here, RC Speed, has given me these prototype tyres here that are made out of rubber and some sort of a stuff in there. But the only thing is, got a join across there. I'm thinking on the join it might go. I don't know.
It's going to explode.
When these blow, they make a mess.
Oh, it's going to
It could go through the
hole in
ceiling.
the ceiling, through the lights. It's going to take your cars out. Look at the 3 ravines there, be gone.
How many RPMs do you reckon it will take?
About 10,000, which is probably about 80 mile an hour.
Here is our dyno rig. We've got the RPM here, so if we spin that, I should be recording it, right? So now hopefully we give it some
This is a bit of engineering here, Kevin.
Hold on.
Oh, whoa, 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 whoa.
We get slow motion camera rolling.
Yeah. Safety first, boys.
You going to stand in the room?
Yeah.
Are you?
Yeah.
No way.
I'm not in the box lid.
That's going to go straight through that, dude.
No, go on, send it.
I'm going out here.
Go on then.
Are you sure?
Yeah, I want to see, man.
You sure?
Yeah, I'm excited to see it.
It might kill you.
Oh, it's not going to kill me. Go on, I'm out of the window.
He's got his goggles on.
No.
Here you go.
Dude, it's come through the door.
I know.
It's like, oh my, Kevy.
Kevin's house.
Kevy.
Oh, look.
Oh, look. Oh,
Where's it gone? It's gone.
Where's the whole thing's gone? There it is. Right, how fast did it go?
Oh, we got to replay this battery.
Oh, look, what's going on here?
Well, we can see what the RPM is where it blew when we work it out. Right, we need to get it on here and see what the RPM was. Oh, don't tell me we weren't reading.
No way.
I didn't read.
No.
So we got no idea what the speed was.
We have to do another one. Yes! Come on, let's get another one. Okay, wait, let me get my protection. This is not safe, guys.
Ready?
Yeah, go on, send it. Look at it! Look, dude, look at all this, look.
Right, hopefully we've recorded the RPM. Alright, let's have a look there. What speed was it? Oh, go back to 0!
Why does it keep going to 0, dude? What's going on here?
I'll do another one.
Oh my god. I'm getting out of the room for this. I nearly got hit then, look.
Right, this is go number 3.
I'm going out. Whoa! Dude, it came out the door! What's going on in here? Dude, look at the roof. Look at it now.
64,000.
No, that's not 64,000. That's 6,400.
It's more than that. What's going on with this thing? There's no way it blew at 6,000, is it?
You have to press
No,
reset.
it's not recording.
Right there.
Right, we've got one wheel left. We do one more, we wind it up slowly in the hope that it's going to pick up the RPM.
Okay.
Maybe I just got on it too quick and it didn't get a chance to. One last tyre, got a bit of paint on there. So now... Is it picking up? Yeah. Right, I'm going to wind it up slower to give this a chance to read the actual reading. I think when we got on it so quickly, it just blew off before we got a chance to register.
I'm actually going out the room.
Right, we're going to wind it up slowly.
Yeah, you stay over there, Kev.
What's in there?
I don't know. Oh, the rubber came off. The wheel's still intact.
Oh, what?
That can't just be the bit of glue, is it?
Did it just come off?
Yeah, it looks like the glue. It's still actually, yeah.
Right, let's have a look on here. 30,000 it got to. So just chucked it in the old speed calculator. We've got the RPM there that the wheel went. And that's the tyre diameter in millimetres. That reckons 338 mile an hour that can do. But when we did it with the foams, that said they did like 400 and something mile an hour. But in the real world, it's only half that. So if that's only half that, they'll probably blow around about 160 mile an hour. So until we chuck it on the car, we don't know. But if you chuck it on the car and it blows up like that, it's game over car.
I wouldn't run them.
Well, I can't run them now, I've got none left. Man, look at this mess. It's gone absolutely everywhere. So I don't know, guys, what do you reckon? Do you reckon it will hold up? I mean, in principle, they did go to 330 odd mile an hour. However, the foams, when we tried the foams, they went up to like over 400 mile an hour. But then in the real world, you're lucky if it does half. And if that rubber blows, you've seen the mess it makes, that's going to completely destroy my car. So, I don't know. I think we'll stick with foams for now. So here, look, we had a Gone Banana go to like 504 mile an hour. In the real world, maybe 200 if you're lucky. So, you know we've been having issues with the Gone Bananas. Well, Mike from Onyx Lipo has saved the day. You all right, mate? What you got for us? So we got some BSRs. I've never used these before. And these are like narrowed and true down to the perfect size. And how fast have these gone before?
We're looking at guys running 223, 224.
So they could maybe get the world record, maybe.
Guess what, yeah.
Alright, so we're going to chuck these on, give it a rip, hopefully they're going to hold up. Any of you guys want to buy any of these, or Onyx batteries, we all use the Onyx batteries here, hit him up, link down below. Put the BSRs on there, nearly my go. One thing that I've done, we turned the power down to 70%. When we came here last time, 100% power, it was just wheel spinning all the way down the whole strip and ripped all the foam off. So 70% power, see what happens, and then we can tune from there. None of us know what we're doing, we're just winging it.
We all playing with toys.
Yes, we all big children.
Grown men playing with toys.
Oh man!
Represent.
Oh yeah, boy. Best country in the world.
A little bit of tape on the front to make sure the body doesn't lift up and get air inside.
Please don't break sausage. There's a lot of work goes into building that thing.
Look at those lights.
Good luck.
There he goes. Woo! Yes!
179.45.
Oh, tyre. Now
So 180 mile an hour on 70% power, and we can still gear it up. This is still geared for the bigger tyres. With the smaller tyres, we can gear up. Man, look at these tyres. Someone has to come out with some tyres that are going to last. Because these are getting silly. That was like 180 mile an hour. Trying to do 250, you're just on the edge of crashing all the time. So, some company out there, please make some speedrun tyres that are going to last. Guys, we've just made a big mistake.
I'm not laughing.
I'm going to blame Robbie.
I'm not laughing.
We're going to blame Robbie.
Wasn't me.
When we were setting it up in Robbie's workshop, one ESC was driving the wrong way, and then I'll sort it later, and I forgot. So what happened was, this motor was going forward, that one going forward, that one going forward, this one running in reverse. So we just did 180 mile an hour on 70% power with one motor going the wrong way, fighting against the other one. But anyway, what it did, it burnt out this ESC. Look, it melted that off. But I think it's taken another ESC out with it. I think we've killed two ESCs. Got one spare one. Maybe I can borrow one off Rob. So another ESC there. Robbie lent me one over there. Also got a brand new motor to put into it. Guys, it's pretty deflated. Not enough sleep for the past few days. I'm absolutely drained, out in the heat. And stupid mistake. And now I've got a wrench on it. And I might have killed the other ESCs as well, who knows. But I want to get some good speed, so I suppose I better man up, stop whinging. Fully grown man, crying about his toy car. Get this stuff in there. I'm going to do it the quicker way. So boom! Got them all in there. Two brand new ESCs. And next up, Andy is going to plug in his laptop, make sure that they all go the right way round. Then we're going to put it up to 100% power and go full speed. We can still gear it up. We're geared quite low. But I'm hoping we're going to get 200 mile an hour as it is. And we can gear up later and try and get more. It's definitely got enough power. It's just dependent on if these tyres can hold up. Here comes Scorch Dave. Whoa, that is quick.
216.79.
Hey.
Oh, 216.
7.14.
217. 217 for Dave from Scorched RC. Oh man, all the tyres gone. Every single one.
There's not a thing left on that.
Well done, Dave. Is that a trap world record?
Yeah, Russell world record that. 224.
Oh shit, look at that, 224.
224.
Hang on, is that a world record?
It's Matty James.
Yeah. That was a tied world record. 1 more mile an hour, he got it in the sack. Get it done, go on.
That is phenomenal. Well done.
Is that one of the new ones, enrollment?
Oh, look at that. I've got my own personal mechanic now. They've all got fed up of me moaning, so they're doing it for me to shut me up. Had quite an expensive day so far, so we've probably done about $500 or $600 of damage on this. And if that wasn't enough, I got myself a nice little Honda generator. I thought, you know, get a good make, it's going to last a while. Nope, she died. Game over, loads of smoke came out, all the circuit board burned out. And Andy's won a little $300 special, trucking away all day. Normally, buy cheap, buy twice. In this case, maybe not. And he's just getting the mesh on the sausage attached.
Done.
Done.
Good to go.
100% power, fully charged, all the ESC's working properly, slightly under geared. Hopefully we get 200 miles an hour if the tyres hold up. You're going for world record attempt number 2, Dave? Oh, no! Oh, dude, game over. Man, just look how high Dave's car went. Those fence panels are over 8 foot high. And it probably went higher than 2 of them. How did it not blow up into a million pieces? Oh, what happened, Dave?
No, we're on it. Could be a tyre failure.
Tumble wumble. Oh no, how is she, Dave?
Crashes well. Crashes well.
What damage we got? Is it alright?
Yeah. Knocked the wings off.
Chassis alright?
Yeah, appears to be. Yeah, broke the little front mount there.
Should you get it fixed and go again?
Yeah, should go again tomorrow.
Scorched tough, baby.
Solid.
Alright, here we go. Oh, by the way, look, we've got a camera on there. So hopefully we can get a bit of onboard. That is a podge, dude.
What is that?
You jealous?
What is that?
Jealous? It's you feeding me all the Isle of Man curries.
It made me have so many curries, it's ridiculous.
How many did you have in the first week, Robbie, you were telling me?
Oh, the first 3 weeks that Kev moved there, we went out 6 times.
Man, my poor toilet's destroyed. I'd have to buy a new one.
Here we go. Nice! What a run, eh?
203.5.
Yeah!
203!
Now.
Well done, Kevy!
Boom! I'll get a new hat!
Yay!
The reason they're rushing is they've warmed up the batteries. I don't want the batteries to cool down. Warm batteries run a lot faster. So my sausage, for example, I didn't heat any batteries, so next run we are going to heat the batteries, and we're also going to use the speed run packs.
This is Stuart, the big man. This is Stuart that runs Rosser, and look what he's got. That is a 200 cap.
Thanks, mate.
No problem.
Oh, nice one.
Yeah, boy!
So next up, they're going to lend me these packs to put into my one. How many volts we're doing?
What is it? 4.35 per cell.
Can't we just do 5 volt?
No.
Oh. So Rob's just charging my lipos and heating them. Oh no, they're cooling down now. Quick, put them back in the oven.
I come with a free lasagna.
Yeah. Please, Mr. Sausage, don't crash, don't backflip, just survive. Here we go, sausage time. We got all the boys in the house, all hands on deck.
Sausage first.
We've got 8 batteries to put in. Right, I can't film, so we just, I'll go quick away, ready? Boom!
Here we go. Hard on it!
So what actually happened was the rear differential blew out, putting all the power to the front wheels. The front wheels lit up, all the foam came off, and now we're along for the ride with no brakes. We're running out of runway quick, somehow threading it through all of these obstacles, and then just coming to a stop right at the end of the runway.
193.15 both tracks.
Is she alright?
Yeah.
Get the coffin open then.
Believe this though, she was at the far end of the runway.
I know, I showed you where you were parked. So I was like, oh.
Look at that. But, you can see that before.
Oh yeah, that happened last time.
Here you go. Present.
What's the rest of it like?
You ready?
Yeah, that's happened before. Oh, what?
Again.
What do you recommend, the diff? What did we get on GPS? I bet it's a bit less. Or, no, it can't be less, can it?
Hey!
202. Now we lost drive to the back. Diff gone.
Oh, that's come loose. This cup's come loose, I reckon.
I reckon diff's gone. You have to try and get those aluminium bulkheads on there. Apparently the ones I bought do work, but you have to change the shock towers. So that'll be a job for next time. The biggest problem with this car, and also, off you come, and also all of my speed cars is the wheels and tyres. They just do not hold up. Look at this, the foam, it just comes off. It cannot take the speed. I've seen so many people say, Kev, use rubber tyres. I've tried, they're even worse. The trouble is with centrifugal force, when it spins so fast, there's so much load trying to pull the rubber or the foam off of the wheel that if you use something heavy like rubber, it's going to be pulling so much harder and it will go even slower. So I'm waiting for a company to come out with some wheels and tyres that are going to be good for the speeds that we're trying to achieve. If there's a company out there that can make something, show them to me. I'll happily show them on my channel and test them. If I think they look good, I'll put them on the car. And if you've got a good product, it's some good promotion for you. So any companies out there, come on, let's get it done. Get some wheels made for these cars. The other problem with these cars is the differential holding up. That is now the second time that I've blown a pinion gear inside the diff. Now, as you saw earlier, the aluminium diff cases that I've got do not fit. However, David from Scorched Parts makes some shock towers that means that I can fit those aluminium bulkheads into that car. Also, Hobeo do an optional gear set where the teeth are a little bit bigger and should give it more power. So aluminium bulkheads and bigger teeth on the gears should make it stronger, and hopefully it's going to hold together. So that's going to go on there for the next video. And wheel and tyre wise, I'm just hoping that someone's going to come out with something. Now, if we look at these plastic wheels, they do cone out, and that probably doesn't help matters. So these are the wheels that Rob made that I forgot to take. They've got a carbon fibre ring inside them, and this makes it a lot stiffer. However, a few people at Rosser actually tried them, and sort of round about 170, 180, it came unglued and the carbon fibre ring slid out. However, they use different glue. Rob's used some special glue on these, and we still don't know. So these could still be an option. And even if not, maybe we can find a glue that's going to hold these in. I mean, it can only help, can't it, if it stays in? Got pretty high hopes for these, so we'll see what happens to these in the future. We still got lots more to come with this car. I've still got to get it at the time of this video, get it to go 225 miles per hour for the world record. And the goal I set myself, I want it to go over 250 miles an hour. So once we get tyres that can hold up, I think we could be in with a chance. So subscribe so that you don't miss it. And don't forget, you can win this brand new Armour Infraction 6S for less than $1. Link down below in the description box. Click here to subscribe and become part of the crew. It's free. Or click here to see one of my other videos.